read an article in the cabin called Teaching for Conceptual Change, Confronting Students' Ideas. And it was an article about a teacher who asked her students what they thought would happen if they put a thermometer inside their hats and their coats and mittens. And the children were absolutely convinced that the temperature on the thermometer would go up. But she didn't correct them. She took them through this process of confronting them with these strongly held ideas they had, because after all, we put hats and mittens and coats on to keep us warm, so they thought that's what warmed up the thermometer. So I read that article and I was just so taken by the teacher's approach and using an interesting question like that to guide student learning that I wrote my first probe, the mitten problem, which is actually in Uncovering Student Ideas Volume 1. I was approached about writing a book, and the first one came out in 2005.
Cross-cutting concepts are for the students to help them organize and make sense of the science. The way we've organized them is around causality, structure and function, systems, scale and proportion, change and stability, matter and energy, and then the last thing, pattern. Cross-cutting concepts have been around a long time. What is a new innovation is the fact that they appear in the performance expectation in the standards, which they'll be assessed with two other dimensions: science and engineering practices and disciplinary core ideas. That's really what's new.
You've spent decades teaching in the classroom yourself. What do you find are some of the biggest challenges that teachers are facing nowadays in the classroom?
Oh, teachers are very much challenged. Just the physical structure and the economic limitations on them in terms of space, time, and funding are important. Large class sizes, lack of equipment in science, all hurt. But also, I think, and I've been encouraging advocacy among teachers, having them try to explain to parents in their community what they do and why they do it is really important. We have the new practices of science, which are really very explainable, and when you sit at a coffee shop or talk to parents in a park, they understand how you're teaching children to discover if you explain it.